Hi, it's Sam from Math. Easy solution here to discuss the definition derivative and look at some examples. In this video, I'll do example one. I just have two examples here, so I'm going to split them up into two videos. I went over actually definition derivative a long while ago, but I didn't go over any too much examples, so I thought I might as well do some right now. So in this video, I'll go over this example one, and then I'll do example two here in the next video. This one, example one, basically states find the derivative of this function f(x) equals x squared minus 8x plus 9 while using the definition derivative over here, and also find an equation of the tangent line 2f of x at the point 3 and negative 6. Okay, so I've written that function down right here, f(x) equals x squared minus 8x plus 9, and now recall from the definition of derivative is written as f prime of x, or derivative of f of x, and this is written as limit as h approaches 0, not x. So you can see in the video link below more on the definition of derivative, and basically this is, we're going to have an f of x plus h all minus f of x, and then divide this out by h. And then to use this definition derivative, all we do is plug in this fx inside this definition right here. So for this function, we'll have the f prime of x equal to limit as h approaches 0 of, now we plug in our x plus h for every single x value, so we'll have x plus h squared minus this is 8x plus h, and then plus 9, and then now we have to minus by f of x, and that's just going to be, well, minus x squared minus 8x plus 9. And yeah, so this is fx and this is fx plus h, all divided by h. And now we could expand this out, so we can cancel like terms. So I'll just drag it down here, equals 2. Well, this part right here, we can expand it out. That's going to be x squared, or just using the FOIL method, we'll get 2xh, and then minus h squared, plus h squared, and then we can go minus 8x, expand this out of the brackets as well, at 8x minus h, and then plus 9, and then at this right side, we're going to have just minus x squared plus, because the negatives make it a positive, plus 8x, and then minus 9, and then all this divided by h. And now we could cancel the like terms, and as you can see, this x squared cancels, so I'll just put an arrow instead, not an x, because there's already a lot of x's. So so we can cancel these out. This would equal now, well, and we'll just see what we can cancel. This 2xh, is there any other xh's? No. This, so that we keep this. Oh, and this h squared over here, we keep it. There's nothing inside. There's nothing else to cancel. This 8x is a negative 8x and plus 8x, so we can cancel this. Cancel this. Now this negative 8h, that's only one by itself, so we leave this. And now this 9 plus 9, negative 9, so we cancel these. So we cancel these two, and now what we're going to be left with is these underlined stuff on the top. So we're going to have 2xh plus h squared minus h, all divided by h. And now we can divide out h on every single equation. There's an h everywhere, so now we can go equals. Actually, before I get to that, I just wanted to quickly change this to limit as h approaches 0. It doesn't just equal this value. So now it equals to limit as h approaches 0, and we also write this. This is just for notation's sake, to be well, just be really formal. So now limit as h approaches 0 of this, and now we could write when we divide it out, we're gonna get 2x plus h minus 8 here, because the h at the bottom cancels with the top. And now we're left with this, and now if we just plug in 0 inside it, before we couldn't plug in 0 because it would be divided by 0 here. So then we plug in 0, and this just becomes 0, and we'll be left with 2x minus 8, and this is equal to our derivative, so f prime of x. So we can box this out. Okay, so now let's look at part B of example 1, which states find equation of the tangent line 2 of x at the point 3 and negative 6 right here. So let's just write this down. Yeah, so at 3 and negative 6, at this point, x equals to 3, y is equal to negative 6. So now the equation of a tangent line, well, we know equation of a line is equals to y is mx plus b right here. Yeah, and we know 3 of these variables actually. We know we could find this b here because we know y, we know m, we know x in this equation because we have this point. This point is on both the tangent line and the f of x value, and m number is just a slope. This is the derivative or the slope of the tangent line, and then this is of x. So yeah, this is the slope of the tangent line, but remember this is at the point where it's on the line here. So on or at the line, and the line is basically at this point here as x equals to 3 right over here. So we have to plug that in. So m is actually f prime of 3, and now if we plug this inside this, we're gonna get 2 times 3 minus 8. This equals 2. Well, this is 9 minus 8. Yeah, and this equals to, well, this is 6 minus 8, so negative 2 here. So that's what m is. So now if we just plug in our y value here, negative 6 or equals negative 6. Let's put an equal sign here. So y is equal to negative 6. We plug in negative 6 equals to negative 2, which is m. 3, which is x, and then plus b to find our b value, and this is just going to be negative 6 equals to negative 6 plus b. This b, 6's cancel, b is equal to 0, and our tangent line just basically y is equal to negative 2x, and that is our line. That's our answer. And now if we were to graph both these functions, I have a graph here with Google graphing calculators and a Google search. Basically, so negative 2x is this tangent line all the way here, and as you can see, it touches at roughly, this is actually at this is plus 3 and around negative 6 right here if you were to draw it all the way here. So negative 6, and this is our f of x, and as you can see, it is tangent to it, and that's how you basically find our tangent line. It crosses the 0. That's our b or y-intercept value. Well, that's all for today. Hope you learned from the this example, and stay tuned for my next video on example 2 right here. And also remember, you can always download these notes in the Dropbox link below, and stay tuned for another math easy solution.